Good morning, everyone. I'm Monia Barbieri and I'm the archaeologist responsible for the maintenance of the Montale Open Air Museum. In this paper, we present the experience, in many ways pioneering in Italian panorama, of the reconstruction which, starting from the archaeological excavation, form an integral part of the park dedicated to the Terramare civilization, inaugurated in 2004 in Montale Rangone, a small town a few kilometers from Modena. As is known, Terramare settlements were widespread in northern Italy, in the central part of the River Po plain, from the Middle to the Late Bronze Age. They were surrounded by an embankment and a moat fed by an herby stream, and their size varied from 1 or 2 hectares in the earlier phases to as much as 20 hectares in the more advanced one. Inside the villages, rectangular dwellings were built either on the ground or on wooden platforms, and were arranged following a predetermined and rational plan that included storage facilities and open areas. In 1868, Carlo Boni, founder of the Civic Museum of Modena, identified the remains of a prehistoric settlement on the hillock of Montale, and 3 years later he started archaeological excavation at the site. Boni's excavations revealed a 4 meters deep archaeological deposit and the remains of the ancient embankment. Despite the importance of the finds, the hillock of Montale was intensively exploited for the extraction of organic soil, like most of the Terramare settlements in the Po River plain. In 1895, of the ancient village that originally occupied about 1 hectare, nothing was left but the area surrounded by the 17th century church buildings, corresponding to about 1/4 of the village's original size. In 1994, the Modena Civic Museum restarted archaeological investigation at Montale, and from 1996 through 2002 carried out the archaeological excavation on the intact part of stratification. The information obtained from the archaeological excavation was so abundant that the project of an open-air museum was progressively developed, in which the reconstruction of the houses, as well as the defensive structures, interacted with the archaeological area originally occupied by the Terramara. The scientific director of the archaeological excavation and of the park project was Andrea Cardarelli, director of the Civic Archaeological Ethnological Museum of Modena until 2003, and now professor at the Sapienza University of Rome. The park project was shared and supported by Ilaria Pulini, director of the museum from 2003 to 2013. Cristiana Zanasi, coordinator of the park's activities since 2004, is currently its curator. The museum reference model was that of Northern Europe's open-air museums, with which a lasting collaboration path was undertaken, thanks to the European project ArcheoLive. The aim of the project was to foster knowledge of the strong cultural unit that characterized the Bronze Age throughout Europe, through the reconstruction of archaeological contexts which, built using perishable materials such as wood and clay, have left few archaeological traces. The partners of Modena Civic Museum were the Pfahlbau Museum in Unteruldingen and the Naturhistorisches Museum in Vienna with the Hallstatt site. Therefore, starting from scientific and methodological basis, the project for the Open Air Museum actually got underway using the skills of the architect Riccardo Merlo and 2 wood construction technicians who work closely with archaeologists. The archaeological excavation involved a surface area of about 45 square meters. A complex stratigraphy, made up of 11 main phases, was unearthed, dated on the basis of archaeological finds and the radiocarbon calibration in a period of time between Middle Bronze II and Late Bronze I, it between the early 16th and the early 13th century BC. The most consistent structural information comes from the first 2 phases, where the presence of post holes and mineralized wooden elements have led to the reconstruction of the floor plans of 2 dwellings and of part of the elevation of the house of phase 2. The houses share the same structural model, and both date to the central phase of the Middle Bronze Age, between the early 16th and first half of the 15th century BC. They were built on platforms raised 110 to 130 cm from the ground, and had a rectangular plan, with a long side of about 9 meters and a short side of between 6.5 7.5 meters. In addition to the alignment of the load-bearing stakes, which supported the roof and walls, stilts were used to support the wooden platform. Both houses had a 3-nave structure with a porch along the south-facing wall. Some of the load-bearing stakes were preserved for a few meters, and their arrangement suggests the existence of an intermediate floor in each house. At the highest point, the roof was probably over 7 meters from the ground. The reconstruction of the two dwellings follow, in a strict philological sense, the indications provided by the floor plans of the excavation, with the reproduction of two three-nave structures with a porch on the long side, where the main entrance is also located. In line with the results of the archaeobotanical analysis performed, oak wood was used for the load-bearing structures, which at the time was widely present in the plain. Currently, the oak is available only in the Apennine, the nearest mountains, with specimens not always suitable to the size and shape for the project. For this reason, sometimes chestnut poles were used for the elevated structure. Some of the work was performed using faithful copies of original Bronze Age axes and chisels in order to experimentally verify the hypotheses deriving from the archaeological data. The house building was carried out according to the following main steps. Digging of the holes to place the poles according to the measurements and floor plans found in the excavation. Erection of the vertical poles using taut ropes to ensure the pole is correctly balanced. The vertical poles have a natural fork at their ends to facilitate placing the horizontal spars. Where there were no forks of the required size, it was necessary to construct artificial joints by inserting wooden plugs. Construction of the platform. Cross members are placed on fixed poles. The wooden floor is created with half trunks placed on a structure which is partly independent of that used for covering. Creation of the double pitch roof. The roofing was made using bundles of swamp reeds, easily available at the time, fixed to the stakes with plant material rope, using a large wooden needle, according to a traditional technique still found in the region of the Po River Delta. Construction of the walls, using a structure of vertical poles positioned on the floor. 3 different techniques were used, recognized on the basis of plaster fragments also found in other terra mare. Weaving of ash and hazel twigs, filling of the frames with branches held down by horizontal stakes, or with bundles of swamp reeds arranged horizontally and again held down by stakes. The analysis performed on fragments of plaster and floor showed that the main components, in varying quantities, are silt, sand, and clay, with a small percentage of gravel and organic material. The plaster was therefore made using a mixture composed mainly of silt loam and secondary of sand, with the addition of small quantities of animal dung. The wooden floor was spread with beaten earth, on top of which a layer of mud and sand was laid. The objects that decorated the two houses are replicas of the originals recovered from excavation at the Montale site, or at other terra mare settlements. Some objects have been reconstructed using experimental archaeology techniques that have allowed us to investigate aspects of production and their use. In the park, the experimental archaeology projects, dedicated in particular to bronze casting and ceramic processing, continued over the years. Economic sustainability and safety requirements have partially limited the application of a strictly philological criterion in the design and building of structures. From an economic point of view, a reconstruction made with the exclusive use of experimental techniques and tools would have required much longer production times and therefore unacceptable costs. The use of modern fastening material in some part of the reconstructions, the presence of structural elements for access to disabled visitors, and the installation of alarm systems and firefighting equipment inside and outside the houses were necessary compromises with respect to the accessibility and safety of the structures, intended for a primary dissemination function and therefore numerically high, about 50,000 visitors per year. The choice to adopt compromises between philological dimension, economic sustainability, guarantee of permanence over time, and evocative impact has also been proposed in the field of maintenance, a priority requirement when dealing with structures in perishable material subject to strong stresses. unlike the more durable modern construction system that provide for the wood to be laid on a masonry base, the construction with poles driven into the ground has the undoubted advantage of being more easily built by few people without the need for temporary works, as each fixture is autonomously stable. On the other hand, modern construction systems generally require shoring during assembly and organized teams of assemblers. The houses of the time had to be easily built and contain a limited number of people. Local failures were certainly tolerated, and the need for continuous repairs and replacement of elements was seen as normal. The reconstructions intended as a museum area must be usable by visitors according to the current safety standards that the techniques and materials used at the time cannot always guarantee. To maintain the construction technique of the time and guarantee the safety of visitors, the following strategy was implemented. Forestry technologies of wood control deterioration of the wooden structures through periodic diagnostic investigations. The correct structural functioning is monitored through periodic tests of both horizontal and vertical deformation of the structures, through precision measurements of the relative position between pointers permanently applied to the bearing structures. As a state of degradation or potentially dangerous subsidence are found, local reinforcements are carried out with techniques similar to the original ones, but also using different materials and techniques, trying to hide these differences. The environmental condition in which the wooden elements are located, very similar to what occurs in nature for dead trees, is crucial for their conservation. Due to contact with bare ground, presence of water and vegetation, the supporting poles of the two houses are subject to a high biological risk, against which prevention and protection measures can be taken that can prolong, but not indefinitely, the operating life of the structures. The main advice of the experts on structures such as those of Montale foresee to maintain the minimum possible environmental humidity, to prevent deterioration phenomena from fungi, periodically check the attacks of xylophagous insects, and replace the wooden elements that are too degraded. In this case, it is useful to remove all the bark and sapwood from the pole, as the heartwood is less attackable by fungi and insects, while it is almost useless to burn the tips of the poles or waterproof them with tar or other. But it is better to provide good drainage so that the water does not stagnate and flows away quickly. The part of the pile driven into the ground is destined to degrade much more rapidly than the one in elevation, due to wood decay fungi, which develop and degrade the wood when the latter is in excessive humidity and lack of ventilation for a long period of the year. To consolidate the bearing poles weakened by the fungal attack, we intervened by placing the single pole on a concrete plinth using a steel spacer that guarantees dry conditions for the wood. The plinth is then hidden by dry plant material. Another intervention involved the installation of diagonal rods to restore the resistance to horizontal actions like wind and earthquake, gradually lost due to the degradation of the poles in the underground part. The use of materials and techniques other than the original ones served to increase both the degree of safety and the durability of the work. We focus our discussion on the problem of wooden structures, the most important for safety, but the other parts of the houses obviously needed intervention too. For example, after 10 years we had to cover the roof ridges with a new layer of reed, while for the necessary restoration of plasters we have recently undertaken a collaboration with a group of architects who deal with green building, and we decided to combine their expertise with archaeological data to achieve a lasting result. The compromise between the experimental dimension and the usability of the reconstructions is an open theme in the open-air museums. We hope that the experience of the Montale Park, in addition to ensuring a longer life of our reconstructions, will make a small contribution to a common problem. Thank you for your attention.